So the addition property of equality is the first property that's on your sheet. And you're going to write things, yes. I tried to eliminate some of the writing so you wouldn't have to do a bunch of redundant writing. So first of all, it says that if A equals B, then A plus C equals B plus C. Makes sense. A equals B, then we can add C to both A and B. A plus B equals B plus C. So what that means is you can add the same number to both sides of your equation. The subtraction property of equality from algebra said that if A equals B, then A minus C equals B minus C. So again, you can subtract the same number from both sides of the equation. Multiplication property of equality says that if A equals B, then A times C equals B times C. So you can multiply both sides of the equation by the same number. And you know from algebra that the division property of equality says that you can, if A times A equals B, then A divided by C is also going to be equal to B divided by C, provided C is not equal to 0. And I didn't put that up here. We know we can't divide by 0. So you can divide both sides by the same number, provided you're not dividing by 0. Lastly, substitution property of equality says that if A equals B, then A can be substituted for any B in any equation or expression. All right, everybody ready? Go on to the next slide. Not quite. A couple more seconds. Everybody good? So the next one says that we are to solve 2x minus 5 equals 13 and give reasons for each of those. So 2x minus 5 equals 13. So we're not necessarily A, B, and C, but what would we typically do? The first one was given to you, the very first step. The first step says to rewrite the equation. So 2x minus 5 equals 13 is given to us. Okay? That's already written. Okay? So the next step then to solving this equation, what's the first thing that you would do? Add 5 to both sides. So you can write it right below it, or you can say 2x minus 5 plus 5 equals 13 plus 5. What's the reason that we can do that? Bless you. What's the reason we can do that? We're adding 5 to both sides. Some people, most of the time, we just do this. Correct? Okay. It's right here where it says solve. Okay. Yeah, we did this last year. What tells us we can do this? What property? Addition. Okay? So our reason for this is the addition property of equality. And you can abbreviate. There's no reason to write it completely out. Okay. Yep, write that down. We added 5 to both sides. 5. So addition ADD dot prop for property equals or equality. Yep. Absolutely. Okay. All right. So when I do this, Trevor, what am I going to get? (2x minus 5 plus 5 is going to be good. Absolutely. We're not used to writing it in one straight line. So you can put the plus 5 below it, and that's okay. Okay? When we do that, our reason for this is just simplify. Okay, all we did was simplify. Okay, now we're going to divide by 2. We're only adding the last 2 numbers, and these guys are going away. Exactly. Is there a problem, Edward? Is there a problem? Mm-hmm. Okay. So we divided by 2, right? What tells us that we can divide both sides by 2? Yep, division property of equality. Just call it div prop equal. Okay. When we do that, what are we going to get? X equals 9. And that's just simplify. We did. We didn't subtract this time. Mm-hmm. Okay, everybody good with that one? Okay. Next property is the distributive property. The distributive property symbolically says A times the quantity B plus C is equal to AB plus AC. And A times the quantity B minus C is equal to AB minus AC. So what this means is that you can multiply each term in parentheses by the number that's outside of it. Parentheses. That would be it. It's okay. All right, everybody got that down? So if we're going to solve this and justify each step, that means that and the first step was written down for you, is to write down the equation and write the word given. That's the equation that we were given. So the next step in solving that is to do what? Most of the time we distribute, right? We take the 2 to the times x and the 2 times 1. So 2x plus 2 is now equal to a negative 4. And our reason, you said you're distributing, right? Abbreviate. Distributive property. What's the next step? So we're going to subtract what? Minus 2. So what's our reason for that? Subtraction property of equality. So when we do that, we're going to get that's just simplifying. What's our next step? Divide. We're dividing by what? So x equals, oh, before we do that, we can do that because it's division property of equality. So x equals, and that's just simplify. Okay. You've just written a 2-column algebraic proof. Why is it what? It doesn't have to be hard, but the reason it's easy right now, okay? The reason this is easy, this is algebra. You're comfortable and confident with algebra. You've been doing this for ages. If we had just given you those properties and asked you to prove them back in Algebra 1, when you first started learning them, you'd think it was hard, right? So we're going to start you with algebraic, which is what you know, and get you the idea behind what we need to see. What are the steps to do this? And then we're going to translate that to geometry. Okay? All right, you've just written two column proofs. My apologies. Okay. So here come 3 more properties. The first one's been given to you. It's called reflexive, and we need it sometimes. In real numbers, it just means A equals A. In segments, it means the distance between A and B is equal to the distance between A and B. And in angle measures, it means that the measure of angle A is equal to the measure of angle A. You are yourself. Okay, when you look at yourself in the mirror, that's you, right? That's a reflection. That's reflexive. You are yourself. Okay? So symmetric is the next one we have to actually do some writing on. So if A equals B, then B equals A. Nope, this one's not written down. The first one, the first row was. Reflexive were. So if A equals B, then B equals A. Okay. For segment lengths, it means that if the distance between A and B equals the distance between C and D, then the distance between C and D is equal to the distance between A and B. And as far as angles are concerned, if the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. So what have we done with all of those? We just switch the sides. Yeah, we don't like to have 5 equals x, right? So we say, we switch it and write x equals 5. Okay, all we're doing is switching the side of the equal sign. So you can write that in a little off to the side. Didn't have room for what it means. So if it feels comfortable or is helpful, write that you're switching the signs of the equal sign. Okay, that's symmetric. The last property is transitive. And transitive says that if A equals B and B equals C, then A's got to be equal to C. That's the real number side of things. If A equals B and B equals C, then A has to be equal to C. Segment lengthwise, if AB, the distance between A and B, is equal to the distance between C and D, and the distance between C and D is equal to the distance between E and F, what do you have to conclude? Well, if the distance between A and B equals the distance between C and D, and the distance between C and D is equal to the distance between E and F, we have to conclude that the distance between A and B equals the distance between E and F. Okay? And it works with angles too. A lot of letters. And it's a mouthful, right? It would be a lot easier just to say AB equals CD. Okay? If the measure of angle A equals the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A will be equal to the measure of angle C. What does this look like? What law did we just study that looks like that? What do you think? Syllogism, exactly. This looks just like syllogism. If P implies Q, Q implies R, therefore P implies R. Okay? There's A equals B, B equals C, so A must be equal to C, just like law of syllogism. Okay? So let's see if we can figure out which properties we're working with here. Good. All right, the first one says, if the measure of angle A equals the measure of angle B, then the measure of angle B will be equal to the measure of angle A. That's symmetric. Good. So right below that, just write symmetric. We can change the side of the equal sign. Okay. The example in the blue box is symmetric. The next one, what do you think? Okay. Kind of looks symmetric, right? Maybe transitive. Reflexive. Transitive. It looks like transitive because there's a lot of stuff in transitive, right? But what's actually happening here? I see a JK here, and I see a JK in my answer. I see a GH here and a GH in my answer. But my original had two distance between a K and L, right? No? What did they do to get from here to here? They subtracted. They took away KL from both sides, the distance between K and L. So this is subtraction. Subtraction property of equality. Absolutely. Because it doesn't fit transitive or reflexive or symmetric, right? So it can be any of these 3, 4, 5, 6, 7, 8, 9 properties. Usually we'll do it one at a time. Should be one. Okay, and I should have written it in a different color. It's subtraction. So we have in transitive, we have a way of getting from one to another. because what we're doing is we're saying the measure of angle A, or if AB equals CD and CD equals EF. So this was just one statement, whereas the other one would have said if JK equals GH and GH equals KL, something like that. It has to have an if and an and. Okay? All right, last examples, or last slide. Okay, next one. Distributive property, good. So this one's distributive because we distributed the 3 to everybody. Nope, you can use all 9. Okay, it's supposed to be distributive, my fault. That's for this one. Guys okay? Okay. Last one. The last one, if x equals y and y equals 2, how do we know that x equals 2? They're equal, so what did you do? We didn't subtract. We substituted. We said if x equals y and y equals 2, then let's substitute 2 in everywhere we see y. That would be substitution. Yes, sir. Yes, sir. Yeah. That was supposed to be distributive, but my smartboard's not cooperating. See how it's giving me way off to the side? All right, so this one is substitution. Assignment's going to be a worksheet in honor of homecoming.